So the second to last family are the halogens. So fluorine, chlorine, bromine, iodine, astatine. So halogens form -1 ions by gaining one electron to fill their valence shell. They like to react strongly with alkali metals, and this also reacts with hydrogen. So a lot of the things you know of when it can form an acid like hydrofluoric acid or hydrochloric acid, the fluorine, the chlorine are the halogens. So the Lewis dot structure, remember that you have to have up to you have up to 8 electrons on the valence shell. So it forms -1 ions. So this is what it would look like for, say, chlorine, Cl, not Ci. So 1, 2, 3, 4, 5, 6, 7. So why would it form a -1 ion? So this actually indicates that for this to have a full octet, notice how in order to become a full octet, it needs to actually gain one more electron to become a full octet. So when that happens, when you're gaining an electron, that means that, well, you're going to have a -1 charge on you because you gained one more negative thing. Like, I know the idea that, oh, I gained something, so it must be positive. Not for these guys. They gain something negative, they're going to be more negative. Kind of like I have more negative things in my life. I'm going to gain one more negative thing. I'll be more negative. Maybe that sounds kind of dark and deep, but you know what I'm trying to say. So they all just have one electron shy of having full shells because they're so close to being happy. They have that trait of being able to combine with many different elements. Elements on the left side, so even like the transition metals, alkali earth metals, alkali metals, they like to interact with these halogens, and we'll see this more often as we go through the school year. So this is actually called a halide when you have halogen combining with another element. So some examples, or actually one of the best, is actually sodium chloride. So somebody in class said, oh, isn't that just salt? No, it's not. Technically, sodium chloride is table salt. Sometimes they make they form covalent bonds, but also, we know that they can make ionic compounds. So, and salts, which we'll talk about more detail later on. I know I keep on saying that, but it's true. So the last family is the noble gases: helium, neon, argon, krypton, and xenon and radon. Sorry about that cutting off on the bottom. So the noble gases, they already have a full octet in their valence shell except for helium. And the reason why it can't have a full octet is because it's only one s2. It only has 2 electrons in it, period. These are for the most part neutral and don't usually form compounds. So how do you draw a Lewis dot structure? For helium, since it's only 2 electrons, you would just do 1, 2. For, say, krypton, 1, 2, 3, 4, 5, 6, 7, and 8. So just some general uses: helium is used in balloons, neon is used in advertising signs, argon, light bulbs, fluorescent lights, krypton is used in high-speed photography, xenon is in headlights for new cars, and these gases, noble gases, can be found in plasma globes, and I have a small one in my classroom somewhere. Starring this up, sort of, except for that last star. You're going to have to be able to recognize these. And I don't know if I'm being too subtle, but you're going to have to recognize these. Hint, hint. So how does a plasma lamp or plasma globe, how do those actually work? So they're filled with noble gases with a high voltage electrode in the center. When a voltage is applied, meaning I turn it on, so a plasma is formed within the container. Plasma is the 4th state of matter, and it is a hot ionized gas containing positively charged ions and negatively charged electrons. So the plasma filaments extend from the electrode to the glass when electricity is supplied. And that's when you get the colored beams of light. Touch the globe, and what happens? You all know what happens. You've seen it. You'll see it in class. So a strand of light connects from the electrode to you. or towards you. Because what happens is that when you actually touch the glass, you create a path that is easier to travel because it's more attracted to you. You're more conductive and you're easily conductive compared to the gases within the glass. So it's going to want to go towards you because you provide the path of least resistance in terms of because your body or our bodies are conductive. So that is it for this lecture for atomic families. We'll talk about this in more detail when we come to class, show videos. You'll see the plasma globe if it still works. But anyways, be safe and take care.